Greenhouse gases. They are important, and we do need them in moderation. The four main greenhouse gases are carbon dioxide, methane, nitrous oxide, and fluorinated gases. Currently in geologic time, these gases are sourced from both human and natural activities. Household and commercial combustion of fossil fuels, solid and organic waste treatment and decay, and use of fluorinated gases for things like refrigerants are some of the human sources for greenhouse gases. Natural sources for greenhouse gases include volcanic activity, organic decay, and the natural release of methane reservoirs. This is a geologic timescale representing the last 850 million years of Earth's history. The red area represents time spans that Earth has been in a greenhouse state, or what scientists call greenhouse Earth. The blue represents colder, icehouse Earth time intervals. The key takeaway here is that 3/4 of the last 850 million years, Earth has been in a greenhouse state. For clarification, according to scientists, an ice age is defined as whenever extensive ice sheets are present in both the northern and southern hemispheres. Also shown on the screen are the big 5 extinction events that have been documented during the Earth's past, along with a period of time referred to as snowball Earth. The events in bold will be the ones discussed during this presentation. Let's get started. We will begin with the Neoproterozoic snowball Earth. Around 3.4 billion years ago, around May 21st on our calendar, early single-celled organisms had evolved to the point where they had developed the ability to photosynthesize. Photosynthesis is where an organism uses sunlight while consuming carbon dioxide and water to produce oxygen and glucose. These photosynthetic organisms were cyanobacteria. Through the photosynthetic process, cyanobacteria would introduce oxygen into the paleoatmosphere. This may not seem like a big deal, but it was rather significant as there was no atmospheric oxygen up to this point. In fact, there was no oxygen at all. It was all tied up with hydrogen in the form of water. At the beginning of the Neoproterozoic, around October 11th, oxygen levels had increased significantly in the atmosphere. The excited atomic oxygen reacted with water, forming hydroxyl radicals, which oxidize atmospheric methane, converting it to CO2. This process decreases the methane concentration in the atmosphere and increases the atmospheric water and CO2 concentrations. Methane traps 84 times more heat per mass unit than carbon dioxide, so carbon dioxide is preferential to methane. But without enough methane, the Earth will cool, and that's exactly what happened. As temperatures fell, glaciers began to form. Since glaciers and snow are white, they are highly reflective of solar rays, so their presence increases the Earth's albedo, or the fraction of light, heat, the Earth can reflect. As heat was reflected, it got even colder, causing the glaciers to get bigger, further increasing the albedo, causing the glaciers to get bigger. You see where I'm going here. Snowball Earth would last for 120 million years, or until the end of the day on November 18th. This is the longest lasting, most extensive ice age Earth has ever experienced. If water is locked up as ice, then erosional processes slow way down. As erosion takes place, the release of alkaline metal ions such as beryllium, magnesium, calcium, strontium, barium, and radium from siliceous rocks withdraws CO2 from the atmosphere. Cold temperatures would also decrease populations of photosynthetic organisms. So for the duration of snowball Earth, CO2 consumption from weathering, erosion, and photosynthesis was at a minimum, and any CO2 that was being released into the atmosphere would simply accumulate, which ended up being a really good thing. And that's what scientists believed happened. Ongoing volcanic activity and oxygen-consuming organisms would come to the Earth's rescue. Due to decreased rates of CO2 consumption, CO2 would accumulate in the atmosphere along with other greenhouse gases such as sulfur dioxide derived from ongoing volcanic activity. As the greenhouse gases accumulated, temperatures would begin to rise. As temperatures rose, the ice would begin to melt, releasing any trapped greenhouse gases like methane. Atmospheric methane levels would increase, causing temperatures to rise even more. This would melt even more ice, and eventually Snowball Earth was gone, a thing of the past, forgotten. Well, it would have been if it wasn't for us rock-loving, meddling geologists. This would bring the Earth back into a greenhouse state of being.